makes dock repairs impossible. Here is a steam shovel loading sand while the tide is out, but it will have to leave soon because in 6 hours would be at the bottom of the bay, covered with 15 feet of seawater. Near the northern Andy, the tidal range becomes tremendous, 50 feet in one locality. A pier 30 feet high is not only dry at low tide, but it may be set in the retreating water by a half-mile or more of beach. Fishing boats lie useless. A dory nests in exposed seaweed. And a ship gone aground has to wait 8 to 12 hours to float again. What causes the tides? The moon, and to a less extent the sun, exert a powerful pull on the earth and cause a bulge in the ocean directly under them. This results in high tide at the place marked by the arrow. On the opposite side of the world, there is a similar bulge. Now, as the earth turns on its axis, notice that at the arrow marker, there are 2 high tides and 2 low tides each 24 hours. But the moon slowly circles the earth, and so the time of high tide is about 50 minutes later each day. As the moon gets to the first quarter position, we can see that it is now pulling at right angles to the sun. The sun's effect is small, but in this position the tides are neither as high nor as low as they were when both sun and moon pulled together. When the moon in its journey around the earth lines up again with the sun, the tides are once more very high and very low. This is the full moon position. The moon in the last quarter position pulls at right angles to the sun, and again the tides are less extreme in range. As the moon completes its journey around the earth, it lines up once more with the sun, and tides of extreme range result. This tide rose 40 feet from the low water mark. We see it now at about 1-hour intervals as it goes out. If we walk over to that distant bluff, we may find some of the red sandstone that makes Fundy beaches so colorful. A tiny stream plunges to the beach and flows through fields of exposed seaweed. Seaweeds near the high water mark must live most of their lives exposed to the air. They are covered with seawater only at high tide. So too are these barnacles attached to a rock. And here a head of stone with seaweed hair. Perhaps by now your exploration has taken you over stretches of beach and hills of seaweed to the very edge of the ocean at low tide. But a glance backward shows that it's a long way to shore, and when the tide turns, you may have to walk very fast or even run to keep ahead of it. As the tide continues to rise, streams stop flowing to the sea and begin to run inland. Ocean water fills the great estuaries whose red clay sides shimmer in the sunlight. When the in-running tide reaches the edge of the grassland, the water begins to creep in and engulf it. During the last half hour of rise, fresh seaweed may be added to that already caught by this fence post. Now let's use the time-lapse camera to watch the marsh being covered with 3 feet of water during the last hour and a half of the tidal inflow. Even farther inland are great barriers of driftwood, floated across the salt marshes by unusually high tides. In the shallow estuary of the Petitcodiac River, a freighter waits for the rising tide. Farther inland, the constricted tidal wave forms a cyclical front of tumbling water. This happens about every 12 hours. Such a tidal front is called a bore, from a Scandinavian word meaning wave or billow. We see it here as it passes the waterfront at Moncton and races on up the river. Similar bores, some much higher, are found in a few places in Europe, Asia, and South America. Tributaries to the Petitcodiac River feel the pulse of the returning tide as the bore passes their mouths and quickly fills them. Now we see the wave fronts advancing in giant curves across the river. About 3.5 miles above the city of Moncton, the front strikes a bend in the river and turns to come directly at us on the opposite bank. Every 12 hours, a Bay of Fundy tide battles the great St. John River, some 450 miles long. Flowing southward, here with a depth of 150 feet, the river is blocked by a natural dam of rock. Over this barrier, the river plunges to meet tidewater on the other side. We see it now from here at low tide. Tons of water pouring into the harbor below, the famous reversing falls rapids of the St. John River. In about 3 hours and a quarter, the rising tide cuts down the outward flow. But this tug still has to fight its way against the current to gain time in picking up a tow upstream. Later, it will bring back a barge during the short period of slack water. About 4 hours after low water, the incoming tide raises the harbor level so that the outward flow of the river is stopped. For perhaps 5 minutes, the two giants, ocean and river, balance each other. This is the slack. Soon the tremendous push of the rising tide begins to force the river backward. After 2 hours, the rapids have completely direction as seawater pours behind it. Against the enormous pressure of the river, the greater drive of the ocean current turns the surface into an impassable expanse of raging, foaming water. A boat can approach here, but would be sucked in and destroyed if it tried to come close on the other side of these rapids. Now let's go over to the other side of the river and watch what happens between the islands. In about 2 hours, the inflowing ocean current has greatly diminished, and the river begins to show its strength. At this point, an experienced boatman rows easily upriver on the slackening but still in-running tide. Circling the island, he rows out to the place where, but a short time ago, a boat could not live in the raging rapids of the inflowing tide. Here he collects boards and timbers from the flotsam. The opposing currents are still strong out there, and when you get sucked into a whirlpool, your boat may spin around out of control for a few seconds. Soon comes the slack and a visible moving edge between the different colored waters of ocean and river. Now the river pushes the flotsam downstream as it bears against the retreating tide. Every half hour that passes, the outward current of the river is swifter, and the channels between the islands and shore soon become impassable mill races of tumbling white water. And now the cycle is complete, at low tide some 12 hours after the last one. The mighty St. John River again roars to the sea, and the froth from the churning water circles like miniature icebergs in the whirlpools below the islands. And so, for as long as the moon circles the earth, the ocean tides shall rise and fall. High water will be followed 6 hours later by low water. But the vast reaches of exposed sea bottom soon again will be covered by the next tidal wave in the eternal cycle of ebb and flow.